Hello, good morning everybody. Today we are going to start the chapter heat. As you know in our earlier classes, heat is a one form of energy. In our nature we have so many energies such as light energy, sound energy, electrical energy, potential energy, kinetic energy, like this. Heat is also one form of energy. In this chapter we are completely discussing about heat and the phenomena which are related to the chapter heat. So once you observe the flow chart of this chapter heat, here heat and temperature. Again we are going to study about specific heat and how to determine the specific heat of a solid and also some phenomena which are occurring in our nature, that are evaporation, condensation and boiling, melting, freezing. Next, latent heat of vaporization and latent heat of fusion. So another phenomenon, temperature. Here we are going to discuss about what is meant by thermal equilibrium state and how to convert the units of the temperature from Celsius to Kelvin and Fahrenheit. Again, we are studying about method of mixtures also. So, first, heat. Heat is a one form of energy. Heat transfers from cooler body to hotter body. So, it is a one form of energy. It transfers from cooler body to hotter body. The units of the heat is calories. In CGS units, the units of the heat is calories, and in SI method, the units of the heat is joules. So, 1 calorie is equals to 4.186 joules. So, calorie is a very small unit. That's why we are using regularly kilocalories. 1 kilocalorie is equals to 1000 calories. So, heat is a one form of energy. It transfers from cooler body to hotter body. So we are regularly confusing with heat and temperature. So what is meant by temperature? So temperature is the degree of the coolingness or hotterness is known as temperature. So by using temperature we can measure the status of the object which is hotter and which is colder. So the units of the temperature is also kelvins. In SI method, the units of the temperature is Kelvin. In CGS method, the units of the temperature is degree Celsius. So here thermal equilibrium state. What is meant by thermal equilibrium state? If any two objects which are having different temperatures contact with each other, at that time what happened? The heat energy transfers from hotter body to cooler body. The transformation of the heat from hotter body to cooler body, how much time it takes place? Here we get one doubt. How much time it takes place? The heat energy transfers from hotter body to cooler body. So here we have one phenomena that is called thermal equilibrium state. So if any two or more objects contact with each other, at that time the heat energy transfers from hotter body to cooler body until both bodies attain same temperature. This phenomena is known as thermal equilibrium state. Thermal equilibrium state. Just we discussed conversion of the temperature from one unit to another unit. Now we are discussing the conversion of the units of the temperature from degree Celsius to Kelvin. So we have one standard value, that is 0 degrees Celsius is equals to 273 Kelvin. In other words, 273 Kelvin is equals to 0 degrees Celsius. So by using this standardization, we can convert the units of the temperature from degree Celsius to Kelvin very easily. So for example, convert 100 degrees Celsius into Kelvin. So adding 100 on both sides of this equation, we get 0 plus 100 is equals to 273 plus 100. So after we get 100 degrees Celsius is equals to 373 Kelvin. So like this, one more example, convert 500 Kelvin into Celsius. We have already known that 273 Kelvin is equals to 0 degrees Celsius. 0 degrees Celsius. To get 500 on LHS, how much number we have to add 273? To find that number, subtract 273 from 500. We get 7, 2, 2. So add 227 on both sides of the equality. So in the same manner, we can convert foreign heat degrees into Celsius by using one formula, that is equals to 9C is equals to 5 into F minus 32. 9C is equals to 5 into F minus 32. By using this formula, we can convert the units of the temperature from Fahrenheit to Celsius very easily and vice versa. So for example, convert 100 degrees Celsius into Fahrenheit. So by using this formula, so here we have to convert 100 degrees Celsius into Fahrenheit. Substitute this 100 degrees value at the place of C in the given formula. We can get 9 into 100 is equals to 5 into F minus 32. So any multiplying factor moves other side of the equality, it gets division. So that 9 into 100 by 5 is equals to F minus 32. So 5 1 5 20 that is equals to 180 is equals to F minus 32. Any subtracting factor moves other side of the equality, we get addition. So that 180 plus 32 is equals to 180 plus 32. How much? 212 degrees. 212 degrees. That is equals to 4. So Fahrenheit is equals to 212 degrees. 100 degrees Celsius is equals to 212 Fahrenheit. So by using this formula, what is the formula? 9C is equals to 5 into F minus 32. By using this formula, we can convert the units of the temperature from Fahrenheit to Celsius. As earlier we have already discussed about how to convert the units of the temperature from degree Celsius to Kelvin. In the same manner, by using this formula, we can convert the degree Celsius into Fahrenheit as well as Fahrenheit into degree Celsius. So heat is one form of energy. It transfers from hotter body to cooler body. So in CGS units, in CGS method, units of the heat is kelvins. In SI method, units of the heat is joules. So It transfers from hotter body to cooler body. So heat depends upon the mass of the object or substance, and also heat depends upon the change in temperature. How? So for this we do some activities which are given in your textbook. Whenever you get visa, read those activities. So I explain briefly. So how the heat energy depends upon the mass of the substance. For this we take two beakers. In one beaker we pour 250 ml of the water. In another beaker we pour 1 liter of the water. So by using any heat source, we are supplying heat energy to the both beakers to attain same change of the temperature up to 60 degrees Celsius in both beakers. So in this activity we observe that the water in the first beaker is 250 ml. It gets 60 degrees temperature in least time, but 1 liter of the water which is poured in the second beaker get 60 degrees temperature in the large time or use time. So by observing this observation, we can say that heat is denoted by the letter Q. Q is directly proportional to M, where Q is the heat energy and M is the mass of the object what we have taken in this particular context. Here we have taken 100 water is the substance. So in the first beaker we take 100 grams of the water. In the second beaker we take 1000 grams of the water or 1 kg of the water. So that heat energy is directly proportional to M, where the change of temperature remains constant. So now we are going to do another activity. In this activity we take 1 liter of the water in any beaker. By applying any heat source, we are supplying heat energy continuously to the beaker, and we are observing the increasement of temperature in that beaker, in that water, in the regular intervals of the time. Here we got one observation. If we increase the heat energy supplied to those beaker, the temperature of those water is also increases. Here mass remains constant. So from this observation we can equate like this: Q is directly proportional to delta T, where mass remains constant. From these two equations we can write Q is directly proportional to M delta T. According to mathematics, any two factors which are in the proportionality relation, where the value of the one factor is increases, at the same time the value of the second factor is also increases. So to remove the proportionality constant between these two factors, we must introduce one constant. So here Q is equals to Sm delta T, where S is the proportionality constant, and also we can call it as a specific heat. So here all these factors multiplying with each other, any multiplying factor moves on the side of the equality, it gets division, so that Q divided by M delta T is equals to S, or S is equals to Q by M delta T. So this is the algebraic expression for specific heat. So what is meant by specific heat? So we can define specific heat as the amount of heat energy. The amount of heat energy required to increase the unit mass of a substance by 1 degree centigrade. So once again, so specific heat of a substance is defined as the amount of heat energy. The amount of heat energy required to increase the temperature of unit mass of a substance by 1 degree centigrade. Again, the amount of heat energy required to increase the temperature of a unit mass of a substance by 1 degree centigrade is known as specific heat of those substance. So algebraically we have already explained S is equals to Q by M delta T, where Q is the heat energy supplied and M is the mass of the substance what we have taken in this particular context, and delta T is the change of the temperature. So by using this formula we can find the units of the specific heat in CGS and SI methods. So observe it. So Q, calorie, heat, mass, gram, temperature, degree Celsius. So in CGS method, the units of the specific heat is calorie per gram degree Celsius. Calorie per gram degree Celsius. In the same manner, in SI method, Q is joules, mass is kg, temperature is Kelvin. So in SI method, the units of the specific heat is joules per kg Kelvin. Joules per kg Kelvin. Okay. So now we are going to discuss about characteristics of the specific heat. So according to the information in our textbook, the water has high specific heat value. So any substance or any material which have high specific heat value means the rate of increasing in the temperature or the rate of decreasing of the temperature of those substance is very slow. Once again, if any substance or any material which has high specific heat value, then those substance has one particular property. What is that? The rate of increasing the temperature of those substance as well as the rate of decreasing the temperature of those substance is very slow. In the same manner, if any substance which contains less specific heat value, the rate of increasing temperature of those substance as well as the rate of decreasing temperature of those substance is very fast. So by doing one observation, by doing one activity, we can learn this concept very easily. For this, we take one beaker and we pour some quantity of water in that beaker. It has nearly 60 to 70 degrees temperature. And also we take two boiling test tubes. In one test tube we take water, in another test tube we take same quantity of the oil. Both are having at room temperature. So by using nut stands, we arrange those two boiling tubes in the beaker for some time. Here what happens? In the beaker we have already poured some quantity of water which is at 60 degrees or 70 degrees temperature. So we arrange these two boiling tubes in which one is filled by water and another one is filled by oil. Both are at room temperatures. So we place these two boiling test tubes for some time and remove the test tubes and measure the temperature of water and measure the temperature of oil. At that time we can observe that temperature of the oil is more than the temperature of the water. How is it possible? Because the specific heat of the water is greater than the specific heat of the oil, so that the rate of increasing temperature of the water is very slow when compared to the rate of increasing temperature of the oil, because oil has less specific heat value and water has high specific heat value. That's why we can say that specific heat of any substance depends upon the nature of the substance. Depends upon the nature of the substance. In our nature, we have so many materials, all which water has high specific heat value. So that's why oceans in our planet, so many seas and oceans are there. Those are called heat stores. So these heat stores or these oceans absorbed heat energy which is emitted from the sun. So if these oceans and seas absorbed heat energy, at the same time there is no significant enhancement of the temperature in their surroundings. At the same time, the in our planet, poles are cooling nature. Poles are having less temperatures, so that these seas and oceans transfers heat energy around the earth and all parts of the earth to maintain equilibrium state on the earth planet. Because sea contains salt water. Salt water is also having the specific heat value 0.95 calorie grams per degree Celsius. So that water has high specific heat value. So, and also if you take any watermelon from the refrigerator and cut it and put those watermelon pieces outside of the refrigerator for some time, what happened? Those watermelon pieces having coldness up to some hours, because in the watermelon the water deposits are very high. So water has the high specific heat value. Due to this reason, any substance or any material which is having high specific heat value, the rate of increasing the temperature of those substance, at the same time the rate of decreasing the temperature of those substance becomes very slow.